Hey there, Algebra 2 students. Welcome back. We are going to look at the last section of Chapter 7 here. And what we're going to do is talk about how to write and apply exponential and power functions. Okay, so we're going to be looking at two different types of functions that have exponents or powers in them. And how do we tell whether we're looking at an exponential function or a power function? Well, it depends on where our input variable is. So if we look at the exponential function here, um, the input variable x, that is our exponent. So we call an exponential function y equals ab raised to the x power because our input is going to be our exponent. Now a power function has an exponent, but we are not going to be inputting values into the exponent. We're going to be inputting values into the base here. So x is going to be our base, and we call that a power function. Now what we're going to do is we're going to look at a few examples of how to write an exponential function, and then on the back side, I'm going to show you how to write a power function. So what we're going to do is we're going to start off with example 1, and we're going to write a function. It's going to be an exponential function, so we're going to use that model y equals ab to the x power, and we're going to write a function whose graph passes through the points 1, 6, and 324. Okay, so the steps we want to do first is I want to take this first point, 1, 6, and I want to substitute that in for the values x and y. So I'm going to let x equal 1 and y be 6, and I'm going to input those values in and write an equation. So what we have here is we have 6 is equal to ab raised to the first power, okay? Now, because we are trying to solve for both a and b, what we need to do, since we have two variables, is we need two equations. We need to create a system of equations. So what we're going to do is we're going to solve this first equation, 6 equals ab. We're going to solve that for a. So I want to divide both sides by b. So I'm going to rewrite this and say a is equal to 6 over b. Okay? Now we're going to grab the second point, 324, and we're going to do the same thing. This time we're going to substitute in 3 for the x and 24 for the y. So 24 is equal to ab raised to the third power. Now we're going to take that value of a that we just solved for, and we're going to substitute it right in there for a. So that's going to look like 24 is equal to 6b cubed divided by b. Okay? Now let's simplify our base. Our common base is b. So b cubed over b is going to make b squared. So 24 equals 6b squared. And now we're going to solve for b. So let's divide both sides by 6. So 4 is equal to b squared, okay? And then that means that b is equal to 2. Now technically, b could be two values. It could be plus or minus 4, but this is an exponential growth function. As you see when we go from the point 1 to a value where x is 1 to a value where x is 3, the y is also increasing. It's going from 6 to 24. So we're going to use the positive value 2. Now, once we've found b, we're going to take that and we're going to now substitute it into our equation for a. Okay? So we know that a is equal to 6 over b, and now we know b is 2. So that means that a is equal to 6 over 2, which is 3. So a is the value 3. So the last thing we do is we plug in now our two values for a and b, and we write the function. So our final answer is going to be y is equal to 3 times 2 raised to the x power. Okay? Now we do not want to multiply 3 and 2 there. That is not equal to 6 raised to the x power because exponents come before multiplication in the order of operations. Okay? All right, so let's go ahead and try that whole process again. We're going to look at example number 2. So again, we are using that our exponential function there, which is ab to the x power. And we're going to first start off by taking this first point, 2, 8, that's on our graph, and plugging that in. So 2 for x and 8 for y. So we should write 8 equals ab to the second power. Okay? Now again, like the first example, we want to solve that first equation for a. So we're going to rewrite and we're going to divide both sides by b squared. So a is going to equal 8 divided by b squared. Now we're going to grab our second point here and we're going to do the same thing. So we're going to let our y be 32, which is equal to ab to the third power when x is 3. And then we're going to grab that a and we're going to substitute it in for a. So we have 32 is equal to 8b cubed divided by b squared. Okay? So b cubed divided by b squared is just b to the first power. So we're going to simplify and say that 32 equals 8b. And then we can divide both sides by 8, and that means that b is 4. Okay, so now we're going to take that value and we're going to plug it into our equation that we've written for a. Okay, we know that a is 8 divided by b squared, and b is now 4, so that means that a is 8 divided by 4 squared, or 8 divided by 16, which is 1/2. So that is the value of a there. A is 1/2 and b is 4. So then we can write our model here, which is y is equal to 1/2 times 4 raised to the x power. So that right there is our exponential function. Okay? All right, so let's look at now example 3. This is an application problem. So the problem says the data in the table shows the number of students y that are enrolled in an elementary school the Xth year the school has been opened. Write an exponential model for the data. Okay, so what I want you to know is that we are not going to be doing any linear transformations. And you might see in your homework, you might see the directions say to take the natural log of y. And what that's doing is doing what we call a linear transformation. So I do not want you to worry about that. What we're going to do is we're going to simply just grab a couple points from the table and we're going to use those to write our model just like we did in the first 2 examples. Okay, so what I like to do is grab, say, like the first point and the last point. Okay, and that way this kind of encompasses all the points in the graph. So we're going to use the point 1, 370, and the point 5, 598. And just like the last 2 examples, we are going to write an exponential function. Okay, so we're going to use that model y equals ab to the x power. So the first thing we're going to do is we're going to plug in the point 1, 370 into our function. So we have 370 equals ab to the first power. And then we want to solve for a. So divide both sides by b, and you're going to get 370 over b is equal to a. Okay? Now we grab the second point and we do the same thing. 598 equals AB to the fifth power. Take the value of A and plug it in for A. So you get 598 is equal to 370 B to the fifth divided by B. Okay? So B to the fifth over B is B to the fourth. So we're going to rewrite 598 equals 370 B to the fourth power. Okay? So now we want to solve for B. So I want you to go ahead and divide both sides by 370. So B to the fourth power equals 598 divided by 370. Okay? The next step here would be to take the fourth root of both sides. So B is equal to the fourth root of 598 divided by 370. Now, technically, we would want to put a plus or a minus there, but we can see that this is exponential growth there, okay, exponential growth, and our base B is going to be a positive number that is greater than 0 and greater than 1. Okay, so grab your calculator and carefully plug in the fourth root of 598 divided by 370, and what you should get is approximately 1.128. Okay, so that is the value of B. So now we're going to take that and we're going to go back to our equation for A. So A was 370 divided by B. So we're going to plug in that value. So 370 divided by 1.128, and that's going to give us approximately 328.01. Okay, so that now is our value for A. So now we can write the function. Once we've solved for A and B, we can write our function as y is equal to 328.01 times 1.128 raised to the x power. So that is our exponential function representing the number of students, y, enrolled in the elementary school x years after it has been open. Okay? All right, so let's go ahead and flip to the back side, and we are going to look at some power models now. Okay, so remember that the power model means that the x is going to be the base instead of the exponent. We're going to follow the same process here, but what we're going to end up doing here is solving for b, which is an exponent, and that means that we're going to have to use our properties of logarithms. So let's start off with this first example. We're going to do it very similar to the last couple examples. We're going to take the point 2, 1, and we're going to substitute it in for x and y. So what we have here is 1 is equal to a times 2 to the b power. Okay? So now we want to solve for a. So I want to divide both sides by 2 raised to the b power. So a is equal to 1 over 2 to the b power. Okay? Now we grab our second point, 7, 6, and we do the same thing. So we're going to substitute in 6 for y is equal to a times 7 for x raised to the b power. And we grab this value of a and we plug him in for a. Okay? So what this looks like is 6 equals 1 over 2 to the b times 7 to the b. Okay? Or 6 equals 7 to the b over 2 to the b. And we're going to condense that and sort of undistribute our exponents, since 7 and 2 both have the same exponent b, what we're going to do is we're going to rewrite this as 7 over 2 raised to the b power. Okay? So now what we have is we've sort of isolated that exponent, and we want to use our rules of logarithms to rewrite this exponential function as a logarithmic function. Okay? So remember that if we have y is equal to b to the x power, then we can write it as log base b of y equals x. So that's what we're going to do here, is we're going to rewrite as a logarithm. So we're going to say log base 7 halves of 6 is equal to b. Okay? So now what we can do is we can use our change of base formula, and we can rewrite this as log of 6 divided by the log of 7 halves. Okay? And that's equal to b. So go ahead and grab your calculator and carefully plug that in. Log of 6 divided by, you could say the log of 3.5. And what that will give you is a value of b, which is approximately 1.430. Okay, so that is the value of b there. Now we're going to take that value and plug it into a. Okay, so then a is going to equal 1 divided by 2 raised to the 1.43. So grab your calculator and carefully plug that in, and what you should get out is a value close to 0.371. Okay, so now that we have a and b, we can now write our power function, which is going to be y is equal to 0.371 x raised to the power of 1.430. Okay, so that is our final answer. That is the equation that models a function that's going to go through the points 2, 1, and 7, 6. Okay, so we're going to try one more example here, example 5. We're going to do the same thing, and we are going to write a function that passes through the points 3, 4, and 6, 5. And I needed a parenthesis around that. Okay, so just like last time, we're using our power model, okay? And let's go ahead and grab that first point and plug in our x and y. So 4 is equal to a times 3 raised to the b power. Okay? Next, we solve for a. So go ahead and divide each side by b cubed. So what you should get is 4 over 3 to the b power. Okay? Now let's grab our second coordinate, 6, 15, and we're going to substitute in a 15 for our y and a 6 for our x. Okay? Now grab your a and substitute it. So we have 15 is equal to 4 over 3 to the b times 6 to the b. Okay? Now we're going to do a little bit of rewriting here. I'm going to show really good work just so you can kind of see how this all works out. So what we have on the top in our numerator is 4 times 6 to the b, and our denominator is 3 to the b power. Okay? Now we want to isolate that exponent b. We want to solve for b. So what we want to do is I'm going to rewrite this again, and I'm going to say 4 times 6 to the b over 3 to the b. Okay? And now I'm going to sort of undistribute that exponent. So I'm going to rewrite it as 4 times 6 over 3 raised to the b power. And now we can simplify. 6 divided by 3 is 2. So 15 equals 4 times 2 to the b power. Okay? So let's see here. We are getting close to isolating our exponent. The next step we want to do is divide by 4. So 15 over 4 equals 2 to the b power. Okay? Now at this step, this is where we want to rewrite as a logarithm. Okay? So let's see here. I'm going to take this guy right up here. We want to rewrite him as a logarithm. So we would say log base 2 of 15 fourths is equal to b. Okay? So in order to evaluate that logarithm, we should change the base. So we're going to rewrite this as log of 15 fourths divided by the log of 2. And now we're using common log base 10. And I want you to grab your calculator and I want you to carefully plug that in, log of 15 fourths divided by the log of 2. And what you should get here is you should get approximately 1.907. So that is the value of b there, okay? And so we're going to grab that and we're going to plug that in to a. So we know that a is equal to 4 over 3 to the b. And we now know that b is 1.907. So we're going to plug in 4 over 3 raised to the 1.907. And that's going to give us a value for a that is approximately 0.492. So there is our value for a. Okay? So lastly, what we want to do is we want to write the power function. So now I'm going to simply plug in my a, so 0.492 times x raised to the 1.907. Okay? So that is our power function. All right? Okay, so you're going to be working on section 7 for the next couple days, and then we are going to start our review for the chapter 7 test. So remember, if you have questions, make sure that you are being proactive and going to the math tutorial lab in F107, and I hope to see you guys soon. Talk to you later.